Yeah, good afternoon. Now today we will discuss the recursion issue. Yes, before that, I will introduce myself. Myself, Dr. Praveen, Associate Professor in School of Computer Science and Artificial Intelligence, SR University. This is my mobile number, 955 and my mail ID p.praveen.sr.edu. Right now, the today topic is recursion in C language. That's right. In our previous videos, I have given functions, pointers with arrays, pointers with two-dimensional array, and structures also. Now today I will give a recursion in C language using some practical system. Yeah. What is the recursion? Sorry? Recursion can be categorized in two types. One is the direct recursion, another one is the indirect recursion. First, why we learn recursion concept? Okay, already we know the functions. With the functions we have written some code. For example, factorial of given number, we have written some code for factorial of given number. When you are use the recursive function, we have to reduce the number of line. That is the size. Actually, in software engineering, we have two categories. One is the size-oriented matrix, and the one is the function-oriented matrix. In size-oriented matrix, based on the number of lines. Okay, we have to reduce the number of lines in the program. So, better if you are implemented recursion concept in when you have developed the project, then you go automatically. You have to reduce the number of lines. That is the main basic principle for the recursion concept. Okay, why? What is the need of recursion? Okay, now see, we have two types of recursion process. One is the direct and indirect recursion. Indirect recursion is nothing but a functions. Okay, one function is calling another function. Okay, one function A is calling B is calling C is calling D. But coming to direct recursion, a function called by itself. It means the function A is calling again A. Right? Function B is calling again B. Okay, many times until the base condition is satisfied. That is the definition of recursion. The function which calls itself is called a recursion. So now coming to this example here, we have function name is A, and we know the main method always your execution starts from the main method. So we have some local variables, we have some input output functions. Some statements are there here. After the statements, we have the one function. Now the function is calling is there immediately the control is from line to called function. Okay, wide here. Now here we have some statements out there, like input output function, some other statements. Again, what is the function name here? Yeah. So now again the function is called. See, now we move to the function. Okay, until the base condition is satisfied. You observe. Base condition is satisfied, then we are input from this function. So now here we write the base condition and the function call. So the recursive functions is designed in three ways, three types. One is the defined base case. Here we have to take care of the defined base case and general case. And another one is we combine the both case and general case. I will give some proper example to this. What is base case? What is general case? So now, for example, wide A, here we write some base case. What is the base case? Suppose you have to find out the sum of n natural numbers. Sum of n natural numbers, we take the value 1 plus 2 plus 1 plus 10. Okay, we don't want to use any loops. Actually, in our previous concepts, we implemented this program by using the for I equal to 0, I less than, you start from 1. For I equal to 1, I less than or equal to 10, I infinity. Sum equal to sum plus I. That's all. Sum equal to sum plus I. So here we don't want to use the looping statement. We want to reduce the number of lines and we avoid the looping statements using with the recursion. So now first we write the base condition. For example, what is the base condition? If here we have a small example, factorial of given number. So if x equal to 1, there is no outcome. Now if x equal here, x less than 0, or what I less than 0, no written any value. Or x, take the read x value, you take x here. X is less than 0, don't want to do anything. The return only 3. Otherwise, what is x is now here? What is the value? Right now, what is the x value here? X equal to 10. So now then else part we have else part is there. Else part we go for the x is greater than 0. So now we write the general case. So first we take the base case, next we write the general case. Now factorial of a given number using with recursion. But I think everyone knows the factorial of given number using with for loop, using with the while loop, using with the do while loop. Now in recursion we are implementing this program using with the for loop. We using with the recursion concept. So program is same in our previous program. Now we are implementing the project. Younger is same, most scanner and you know the value function. You have to the control is immediately jump from main to called. In this called function, we have to write the base case, we have to write the general case. That is base case is we take some x is n is 0 or n is 0 or n equal to 1. 0 factorial equal to 1 and 1 factorial is also equal to 1. Base case is if n value equal to 0 or n value equal to 1, then you can return only 1. Otherwise, we go for the general case. Clear? I want to show the program also. Now see this one. Into factorial. Yeah. What is the x value of previous variable? 5. Yes. N value equal to 5. Now go to this one. Here. X equal to 1 or x equal to 0. X equal to 1 or x equal to 0, then you can return. So now the control is your base condition is satisfied. Now what is the first initial value? You take the initial value, take the, for example, 1. Yes, 1. So x equal to 1, return 1. Base condition is satisfied. Okay. General case is nothing. So for example, now I want to enter n value equal to 5. Now 5 equal to 1, no. 5 equal to 0, no. So control is from condition to yes. This is a written x into factorial of x. Now I want to write here x equal to 5, right? Now written x into, which means 5 into 5 minus 1. 5 minus 1 means now x value equal to 4, right? Return x into, what mean by x? 4 into factorial of 4 minus 1. Factorial of 3 minus 1. 3 minus 1. Now x equal to 2 into factorial of 2 minus 1. X equal to 1. Right? X equal to 1 into 1 into 1. Observe here. Now the base condition x equal to 1. So this is a return. What is the value? 1. Return 1. So you observe here. Return. Now this will be return. Now 2 into 1. 2 into 1 return 2. Now this will be return 2. Okay. Now 3 into 16. 6. Return 6. 6. 4 into 6. 4 into 6. Right? 24. Now 24. Now this will be return 24. 24 into 5. 120. Now 120 is a return. You observe 120 is a return from calling function to where is the function? Calling function to calling function. Now the value is 120. 120 is also equal to 5. You put into the factorial. Number using the progress. Right now, actually, in our previous progress, it's the file. Now, without filing, you wrote the factorial file. Using with the cursor. Simple, you write only one statement. That is a return x into factorial x minus 1. That's it. Okay, let's take one more example for a recursion. GCD of two numbers. We find out the greatest common divisor for two numbers. Okay, now the number n and m. We have entered two numbers. One is called n and one is called m. So we send these n and m values to the calling function to call function. Observe here. Suppose I want to enter n value and m value 10 and 20. Now GCD of 10 comma 20. Right? From calling function to call function. You observe here b equal to, what is the b value? B equal to, now here we enter 20. A value equal to 10. Now it is not satisfied. Then go to the next. Return GCD of b 20 comma 10 mod 20. 10 mod 20, what is the value? 10. 10 mod 20, 10. Alright? Okay, next one. 10 mod 10. Okay, we continue until this condition is satisfied. Then we send the value, it is called 10. And is the greatest common divisor. And one more very important program in the recursion concept, that is called the Fibonacci series, using with the recursion. Fibonacci series using with the recursion. See, we want to find out we want to print the Fibonacci series until n value. So now the n value here is box n equal to, what is n value? Is 5. Fib of 0, fib of 2. N value, x value equal to, that is x value equal to 0, x value equal to 1, x equal to 0, x equal to 1. Now, first initially, what is the value? 0, return 0, equal to 0. And I value is updated, I equal to now 1. Now, return 1. Return 0, 1. 0, 1 is completed. Now, the I value equal to 2. I value equal to 2. Now, fib of 2. Fib of 2. The control is changed. Now, this condition is not satisfied. Return fib of x minus. What is x minus? X value equal to 2. 2 minus 1. 2 minus 1. 2 minus 1, 1. You observe. 2 minus 1, 1. 1. X value equal to 1. Now return what is the value? Return value 1. And x minus 2. What is x minus 2? X value equal to 2. 2 minus 2, 0. That return is now yes. 0 plus 1. 0 plus 1, 1 return 1. Right. Now I value is incremented by 1, I is equal to x equal to 3. Now it is not equal. Fifth of 3 minus 1. Fifth of 2. What is fifth of 2? Already we have a value fifth of 2. Fifth of 2, 1. Right? And next, fifth of 2 minus 2. 2 minus 2 means that is called 3 minus 2, sorry. 1. Now what is the value? 1 plus 1, the value is 2. Okay, next to 3. We have to add the previous term. 1 plus 1, we return 2. 1 plus 2, we return 2. 2 plus 3, we return 5. 3 plus 4, right, that's it. Now, I value equal to 4, I value equal to 5. Then we will get this outcome. This is about the Fibonacci series by using recursion. Here guys, right, and here we have the code for the Fibonacci series. X equal to 0, x equal to 1. Return x. Otherwise, return fib of x minus 1 plus fib of x minus 2. That is x minus 1. The value will be returned first initial 0, 2 minus 1, 1, and 2 minus 2, then 0. Now, the next one is the displaying n elements. Displaying n elements on your screen. Now, you need to display in text x equal to 0, return nothing because there is no need to and display x minus 1. So, now x value equal to 5, 5 minus 1, and 5 minus 1, 4. Okay, print x, 5 minus 2, 5 minus 3 is 1. Now, towers are coming, and we know this is about recursion. I want to execute the program from the recursion. C++. I think it is visible. So here, it is visible. Now the program is the right here C program to find sum of n equal using Recursion. This is the program. Hash include the theory of main method. And, so now you have declared some variables. You need to, what are the variables required? N is required. Right? N is required, comma, return value that is indicated with the R. Printf enter n value. Now, somehow, very, very, is equal to first statistic what always the value now the function is not into one. Normal variable is open bracket. What are the variables required here? No variables are required. First, if x equal to 1, x equal to 1, return Otherwise, you type sum of x minus 1. X plus sum of x minus 1. That's it. X plus sum of x minus. Now we see with the recursion. It does equal. If there is no error of theory, go for sure. So now it is visible. Enter another. Now I want to enter 10 value. Sum of 10 natural numbers equal to 50. Right? That is called 1 plus 2 plus 3 plus 4 plus 1 plus 9 or 10. So the output is 55. This is the sum of n moving equal recursion. Now go to the program. Just want to change this small code. Now go to program, find Factorial yes. Factorial give it. Now there is no difference here. Just I want to change the function name. Factorial of 1. So of 1 is equal to. Go to the all different function. Change the function name. Data x equal to initially 0. 0 factorial is equal to x equal to otherwise there is just to change the function name is the function return x equal factor of x minus 1. Now we save the program, compile run. No errors, I think. Go to application window and now it is visible. You check the number value equal to 6. I want to enter the factorial of 6. Factorial of 6 equal to 720. Okay, 5 factorial is 120. 120 into 6, so 7. This is about the factorial of given number using the recursion. Right, clear? Okay, now I want to take the one more program. Now, the program is the Fibonacci series. You have to do Fibonacci series, and one more is G series, 2 numbers. Now, these are the very important programs in the curriculum. Okay, most of the times Fibonacci series factorial number is in your editor exams. So, this is the program. Recursion. The next concept is the you print the local variable in the global variable. What is called the local area of the global area. See, what is the scope of the variable? Now, scope of the variable is 2 ways. One is local area and one is the global area. Local area variable is accessed within the function. And outside the function, that variable is the undefined variable. And global area means when you are declared before the main method, that variable is called the global area or global variable. That variable is accessing anywhere in the system. right? It is the place where variable can be used. Two ways, local block, global anywhere in the program. Now, local area, block is symbol and not statement. Enclosure is set on box. Variables in local area exist only from the point of the declaration until end of the block. It means now I want to declare main integer. We have some other statements. Close the count. Now this is one block. In this block, A is active. Suppose I want to take one more question. It is another one. In another block, A is undefined variable or undeclared variable. Outside the block, they are invisible. They are invisible means that variable is not acceptable. That variable is the unknown variable. You remember this part. Okay, clear? Within the block, that variable is acceptable. Outside the block, that variable is not acceptable. Now, local area, local variables. Now, what is that? In A equal to 6, A equal to 10. What is A? This is a local variable in main. But in this main, another block is there. In this block, the same variable is repeated. Observe, same variable is repeated. So, which is the local variable in this block? 10 is the local variable. And what is the output of variable A? 6. Now, what is the variable A? 10, comma 6. Here it will be displayed 10. Here it will be displayed 6. That is called the local variable. The global area. Global area of our program consists of all statements that are above the main function. To simply remember, actually our C program can be divided some parts. First one is the comment, that is the documentation section. Documentation section, you have to write the program name of the developer, and your date of execution. And next, you declare the linkage section. Linkage section means you declare all header files. After header files, you have to declare the prototyping section as well as a global area section. Global area means global variable declaration. Okay, even this declaration variable is accessed anywhere in the program. It means main method, this is acceptable. Outside the main, this variable is the acceptable. That is the difference between local area, local variable, global variable. Local variable is accepted only in the block. Global variable is accepted anywhere in the program. That is the difference, right? Now coming to the example. Why display? So what we have a prototyping, that is display, and before this why display you have a hash input stdio.h and int a equal to 10. Observe. Int a equal to 10. This is the node. Now what is it? You declared any variable here. So this will be displayed 10. Suppose I want to display in this block int a equal to 20. Now what is the output of this A? You have a global variable here, same name with local variable. So first priority equals to local. Next, if the local variable is not available, then you take the global variable. So if you have int in this block, then it will be return the values, right? This control is input from. Now A equal to A. What is E value here? E value is from 10%, right? And now this value is a reflected here. That is the local variable and the global variable, right? Global variables are accessed to the outside. Now, based on this local variable or local area, all the variables can be categorized 4 types. That is the storage classes called auto storage class, register, static, and one more is the external storage class. Now, auto storage classes are default storage classes. Okay. Actually, in our previous programs, we declared just int a. There is no precedes, but this variable is default. This variable is the auto variable. Now, coming to the storage class of variable reflects the scope and length of the variable. Reflects within it. There are four storage classes. Scope of the program is it acceptable in order to model lifetime within the model or outside the model? Is it the lifetime of the variable is there or not? Okay, now total four storage process that is called auto, register, static, extra. Now coming to auto storage process, these are declared with the keyword auto, but it is optional. All local variables are by default automatic variables. Remember this point. All local variables already we declared int a, right? Main int a. Now this is the auto variable, automatic variable. Without keyword auto, that is considered as a auto variable. Now scope and lifetime within the block. Because why? Because local variables are acceptable only within the function or within the block. And next, now coming to example, int I for I equal to 1, I less than or equal to 3, I plus 6. Auto x equal to 0. Auto x plus x value equal to 1. Okay, I value is updated. I equal to now, I value equal to now 2 less than or equal to 3. Yes, auto int x. Now again x value equal to 0. X value equal to 0. X plus plus 1. 2 into 1. 1. That is the usage of auto variable. And next, register variables. These variables declared with the keyword register. Okay, actually, this variable is actually reside in the any variable is reside in the secondary storage. But coming to see register, when you are declared with the register keyword, that variable is stored in the CPU registers. The declaration specifies a recommendation to the compiler to use the CPU registers for the variable instead of memory location to reduce the accessing time. Already we know. First we check into the primary memory, next we check the second. Before primary memory, our variable is available. So we don't want to check into the primary memory. We don't want to move from primary memory to secondary memory. Now that variable is available in the CPU registers. So then automatically we can reduce the access time. That is the main advantage to use that register. So now suppose I want to declare all variables declared as a register. But the system, the compiler doesn't take like this. Only few variables are considered register because the registers are very small variables. That's why we take one or two variables for the register variable. This lifetime and this scope is within the block. So now the program is CBD variable register int x equal to 1. So you print the x value. So now register one advantage to text is referred in the PC. Remaining everything similar to our auto. That is the order. And next one is the static storage class. Static storage is very important in Java language. Now static can be categorized into types. One is the internal static and one is the external static. Internal static is nothing but local. External static is a global variable. External static is the global variable. Now, these variables declare the keyword is all global variables are default static. Now, static variables will be local and deep. Okay, within the block that is local block. Outside the block that is the before the main that is the global. Now, lifetime is the untyped program. These variables are issued only once in the program. The default is being stored with values, but I want to take static integer. So, what is the value of x, this will be written here. Why? Because the dot is removed from this because zero is assigned to the. That is the advantage to use the static variable. Now, I equal to 1, I less than or equal to I. Previously, same program, using the dot, using the register, it will return 1, 1, 1. But now coming to this program, into x, right? Now x value. We are not assigned any value to x. Any value to x. But default x plus what is it? 0 plus 1. Now this is a all variables are shared in the same memory location. Now x value equal to what is x value? X value we have got 1 is assigned. 1 plus 1. Now x value equal to 2 is assigned. Now 2 plus 1. Now the value is 6. So 1, 2, that is a static. And last minute, the external. Now, external variables mean purpose to use that. Okay, now one more example for the static variable for the global declaration. Static. See, static input function. I want to now with number. 1, 2, 3. Again, function. Right? Go to the x value. X value equal to 1. Not function 1. Now control is changed to here. Control is jumped to here. Now it will also return the 1, 2, 3. Yeah. Now external storage class. When there are multiple files, suppose you have a file 1, you have a file 2, you have a file. Now only one variable is required in this variable, in this file, in this file, in this file. We don't want to use multiple times. We create only one time, that is use it in the other time. When there are multiple files in a program and we need to use particular variable in a file, apart from the keyword external variables are global. These variables are given and access to one time. Importing this variable, this file importing this variable, okay? This way. Now we declare that file to dot, file to dot. We are creating the header file already. We have the header file which contains something. That file name is the file to dot. Now into x name x value. What is the x value? Display function is written in the file. Display function is written in the file. Now we move to the file to observe file to. We write the value from file to display. Control is jump from near to display. Now this is the separate function. Void display. X equal to x plus. Now here x value equal to x value equal to 10. Here x value equal to 10. Now this 10 is the external. Here go to the control display function external into x. So external into x means this value is 10. This value is 10. Now 10 plus 10. That is 20. Look into the 20. Right? And the control is jump from display function to normal. What is the x value here? X value equal to 10. This is the external storage class. Okay, total how many storage classes we have? We have 4 storage classes. One is the auto storage class. Second one is the register storage class, static storage class, external storage class. Okay, auto storage class is the default storage class, like a register. That is nothing but auto. Okay, the main advantage to use the register variable, this variable is stored in CPU registers. When you access these elements, you don't want to check into the memory. This variable is available from the CPU register. That is the major advantage to use the storage class. That clear? Next one is the static variable. Static variables are global variables. Now, actually, normal variables, if you have displayed the, you don't want to assign any value to the variable, just you display the value, garbage value will be written. But when you have declared this garbage, the garbage value is removed from the function, right? The value that is 0 is displayed. That is called static. And one more variable is the external variable. This is a global variable. Sometimes the same variable is reflected in multiple files. So we put the if available is the variable is available. But this is the external storage class. Right here, this is the external and we covered the Recursion concept, we covered the storage classes. Now I want to show one program for all storage classes. Start here. Equal to we got D plus plus. Right, one program. Right in the program. So come on. So use class. Crash record is 3D and 1. Is a simple. Open bracket is equal A equal to 1 to 1. I don't care percentage E common, right? Take one function display white display the variable is in that percentage E common. Now I want to execute this method. Compile and run. You have to here this is variable is error undefined variable. Why it is undefined variable? Why it is undefined variable? So A is not A is declared in E. Is indefinite. So I want to deploy here into A 1030 is assigned to B. Now again we are in 45 and plus. So now there is no error undefined display. Yeah, it is a yes. Very good. Mistake. Compile and run. Yeah. Stop changing. Go to now all of you look here 10, 20, 30. 10 is the local variable. 20 is the main function. We declared one more block. In that block, 20 is there. That is displayed. And one more is the 30. 30 is the global variable. This is the simple program on storage classes. Now, start with the program. Okay. Now here I want to tell the static int x int f percentage Yes. Okay, now this is the external variable. You put the external key. Now, static will take the will take the possible set. And register automatically that is already we know. 10, 20. They will show what are we going to take back any new line, new line, new line. Compare. There is no error. Stop there. There. Now 10, 20, 0. This is the output of our storage process static. Here, now this is about the programming on storage process. And next video, we will see the dynamic memory allocation. Thank you, one and all.